show that root 2 is an irrational number. To prove this, firstly one must aware about a rational number and irrational number. Rational numbers means what? Means rational numbers can be represented by q, and rational numbers means the numbers which can be written in the form of p by q, where p and q are integers and where q should not be equal to 0. Q should not be equal to 0. And what about irrational numbers? Irrational numbers are represented by q dash, and the numbers which cannot be written in the form of p by q are said to be as an irrational number. Now we need to prove root 2 is an irrational number. That means we need to say that root 2 cannot be written in the form of p by q. For this, firstly we need to assume that it is a rational number. That means we need to take a completely opposite to the what we need to prove. We need to prove it as an irrational number, but I am taking it as a rational number. And if it is a rational, then there must exist two integers p and q, where q is not equal to 0, such that root 2 is equal to p by q. What does it mean? It means, as suppose that root 2 is a rational number, and if it is a rational number, it can be written in the form of p by q. From the definition of rational numbers, we can write it as a p by q. Now, if p and q have a common factor other than 1, then we divide that by common factor to get root 2 is equal to a by b, where a and b are a and b are co-operands. A and B are co-operands. What does that mean? Means if you take a fraction, let us take 15 by 12. 15 by 12. It is a fraction. It is in the form of p by q, and it is not in the simplest form. That what does it mean? Means 15 and 12 are having a common factor other than 1, that has a 3. That means on dividing by 3 this both of the numerator and denominator, then this can be written as 3 5s 3 4s. That means this 15 by 12 can be written as 5 by 4. Now we can say that it is in simplest form. It is in simplest form. Why we are saying it is in simplest form? Means here numerator 5 and denominator 4 both are having only one common factor, that has a 1. That means there is no other common factors other than 1. That means what here means, if you take a root 2 as a rational number, I wrote p by, it is in the form of p by q, and if there exists a common factor other than 1, and with that common factor I am dividing this both numerator and denominator, I will get root 2 is in simplest form as a by b. Now if it is written in the form of a by b, then a by b, that means a and b are said to be the co-operands. This word plays very important role in this solution. Why? Because here co-operands means you must understand that there is no common factors other than 1. In proving this as an irrational number, we are going to prove there is a common factor other than 1. But what we are supposing here is, we are supposing it as there is no common factor other than 1. But what we are going to prove means, we are going to prove there is a common factor other than 1. Let us see how we are going to prove that. That is, if you take root 2 is equal to a by b, on squaring both sides, this can be written as root 2 the whole square is equal to a by b the whole square. This can be written as 2 is equal to a square by b square. Now on transposing this b square to other hand of equation, this can be written as 2b square is equal to a square. On rearranging the terms of this equation, this can be written as a square is equal to 2 into b square. A square is equal to 2 into b square. Let us assume that it has an equation 1. Now from this equation, what we should understand means 2 divides a square. How we are saying that 2 divides a square? Means if you observe, this is equation 1. Equation 1 says that a square is equal to 2 into b square. That means a square, I wrote it as 2 into something. 2 into something. That means a square is a multiple of 2. A square is a multiple of 2 means a square. That means 2 divides a square. If you take any multiple of 2, just like 16. 16 is a multiple of 2. Then it is divisible by 2 or not? Yes, it is divisible by 2. In the same manner, a square is a multiple of 2 means 2 divides a square. That is what I wrote. 2 divides a square. In the same manner, if 2 divides a square, then 2 divides a also. This is a theorem. There is a theorem in your class 10 that by using that theorem, we can say that 2 divides a. Then, if 2 divides a, 2 is a factor of a. 2 is a factor of a, and a is a multiple of 2. A is a multiple of 2. Just like this. 16. 2 divides 16. So 2 is a factor of 16. And 16 is said to be the multiple of 2. In the same manner, if 2 divides a, then 2 is a factor of a. Then a is a multiple of 2. If a is a multiple of 2, then a can be written as 2m. Because a is a multiple of 2. So I am supposing that a is equal to 2m. And this a value of a is equal to 2m, I am going to substitute in our equation 1. What is our equation 1? That is of a square is equal to 2b square. In this I am substituting that a is equal to 2m. On substituting that, I can write that equation 1 as a 2m the whole square is equal to 2b square. From this, I can write it as an 4m square is equal to 2b square. 4m square is equal to 2b square. Now, on transporting this 2 to other hand, we can write it as an 2m square is equal to b square. From this b square, I can write it as an 2 into m square. Again, if you observe this, b square is written as 2 into something. That means b square is a multiple of 2 means 2 divides b square. If 2 divides b square, 2 divides b also. If 2 divides b, then 2 is a factor of b. That's what I wrote here. 2 divides b square, then 2 divides b also. That means 2 is a factor of b. 2 is a factor of b. But what we got in the previous, we got that 2 is a factor of a. In this statement, we got 2 is a factor of a, and in this statement also we got 2 is a factor of b. That means we can say that 2 is a common factor of a and b. But what we suppose, a and b are co-primes in the beginning we considered. That means this contradicts the fact that a and b are co-primes. Why we got this contradiction? Means this contradiction has arisen because of our assumption. That root 2 is a rational. So we can say that our assumption is wrong. If our assumption is wrong, then root 2 becomes a irrational number. Therefore, we can conclude that root 2 is a irrational number. Thank you friends for watching this video.